Picture this. You're sitting in the exam hall. The clock's ticking. You flip to a standard pseudocode question, write down what you think is a perfectly logical answer, and move on. But you just lost the marks. 9 out of 10 students actually get this specific syntax wrong, and it quietly costs them the grade before the examiner even reads the rest of their logic. So let me show you this massive mistake right now before you ever step foot in that exam room. Look at the example on the left. That 10 equals score, I call that the red pen trap. It looks like math, it feels completely intuitive, but in IGCSE Computer Science 0478, it is dead wrong. Now look at the correct answer on the right. Score, left pointing arrow, 10. In this explainer, we're going to tear down these exam traps, rebuild your understanding using some really clear visual steps, and upgrade your answers to be exactly what the Cambridge mark scheme demands.
All right, Section 1, Mastering Pseudocode Assignments. Let's get right into it.
Let's start with the absolute simplest layer. The assignment operator isn't just an arrow, it's an actual action. It tells the computer to evaluate whatever expression is on the right side of that arrow and then securely store that final result into the variable named on the left. It is always right to left. And you know what? That right there is the fundamental logic of computing. Check out those data streams flowing from right to left. That's your logic in motion. Direct your eyes over to the mechanism and logic section on the right side. We're looking at two main actions here. First up is overwriting existing data, meaning when a new value comes in, the old one is permanently destroyed, gone. Second, we have self-assignment, which is exactly how we do totaling. Notice the format, total, left arrow, total plus new value. You are literally taking the current value, adding to it, and overwriting it all in one swift motion. The real key is knowing exactly where students trip up. Welcome to the Common Mistake Clinic. First, the equals trap. Listen, never use the equal sign for an assignment in IGCSE pseudocode. Equals is for comparing things, not for storing them. Second, incorrect variable order. You absolutely cannot write 10 left arrow score. The storage box, the variable, must always be on the left. And finally, a quick bonus trap. Never confuse validation, which checks if data is sensible, with verification, which simply checks if it was copied correctly. Master these and your syntax is going to be bulletproof. Moving right along, let's look at decoding the digital alphabet. Before we can even talk about the modern internet, we have to understand the origin story of our digital alphabet. Chronologically, we started back in the 7-bit era with the original ASCII blueprint, which honestly was basically just built for English. Then, as hardware improved, we pushed into the 8-bit era, giving us extended characters. But finally, as the whole world's connected, we desperately needed the modern era, which is the Unicode Universal Language Standard. This graphic brilliantly captures that exact evolution. See that blocky blue glowing letter A on the left side? That represents the original 7-bit ASCII foundation. It was incredibly efficient for its time, but it was strictly limited by early hardware to just the English alphabet and basic control codes. Now pan your eyes over to the center and the right. That vibrant glowing sphere covered in all those global scripts, that is Unicode. It's the universal language. Unicode was the massive breakthrough we needed to represent every character from every language, creating a truly global data standard. So now a message sent in Tokyo displays perfectly in London. So how exactly is an examiner going to test this? Well, they'll ask why we moved to Unicode. A weak one-mark answer simply says, for different languages. Frankly, that's just not good enough for us. The strong, high-level exam transformation explicitly targets the hardware. You need to explain the limitations of ASCII's character set versus the critical need for global data standardization. That specific precision in your terminology is exactly what's going to elevate your grade. Next up on the syllabus, the fetch-execute cycle. Welcome to the Silicon Brain. We're visualizing data not just as abstract text, but as tangible, high-fidelity streams physically moving through circuitry. And right there in the dead center, highlighted by those glowing blue and orange arrows, is the heartbeat of every computer on Earth. This is the fetch-execute cycle. Every complex software action, from running a high-end AAA game to encrypting a password, is literally just millions of these exact cycles happening in a rapid, continuous loop. Let's break that spinning wheel down into a simple, exam-ready, 3-step sequence. Step 1, fetch. The CPU retrieves a specific instruction from the computer's memory, the RAM, and pulls it right into its own internal registers. Step 2, decode. The control unit takes that raw data and interprets it to figure out exactly what operation is needed. Step 3, Execute. The CPU actually carries out the instruction, often using the arithmetic logic unit, or ALU, to process the mathematical data. Fetch, decode, execute. Repeated millions of times every single second. All right, time to shift gears to internet safety answer strategies. If you want to grab maximum marks on internet safety questions, you need to focus on these 3 distinct layers shown on the left. You really have to train your brain to process topics this exact way. Layer 1 is simple language. You just conceptually understand the risk. Layer 2 is technical vocabulary. This is where you start using subject-specific terms instead of everyday words. But Layer 3? That is where the magic happens. The exam response. This is where you shape that technical idea into a concise, high-scoring answer specifically designed to perform under intense time pressure. Consider this table your ultimate cheat sheet. The strategy completely changes depending on the question's command word. If it asks for a description, your winning strategy is to clearly name the concept or device first. If it asks for an explanation, you've got to explain the mechanism step by step first and then state the consequence. But listen closely. Here is the golden rule for application questions: contextual connection. If the exam scenario is about a bank's internet security and your answer talks generally about users, you are going to lose marks. You must specifically talk about customers, financial data, or bank servers. Apply it to the given environment. Which brings us to our final section, the examiner's final playbook. I want you to focus entirely on those interlocking gears right in the center. That is your high mark answer engine. You see, an examiner isn't just looking for a random collection of facts. They're looking for a machine that works perfectly. Your answer needs 4 gears turning together seamlessly to crank out those full marks. If even one gear is missing, the machine stops and the marks stop. It's that simple. So, here are the 4 gears you absolutely must spin up every single time. 1. Identify the exact digital concept. 2. Provide specific data or evidence. 3. Apply scientific reasoning, meaning explain exactly how the process works and why it matters. 4. Shape all of that using precise syllabus wording. And a huge warning here, avoid the surface feature trap. That's when a student just describes what a device looks like on the outside, instead of explaining its internal mechanism and sequence. Always focus on the unseen mechanisms, not the outer plastic shell. So I'm going to leave you with a final, provocative scenario that totally synthesizes everything we've covered today. Think about this for a second. If a retail checkout processes card data, how does the hardware's fetch-execute mechanism, combined with Unicode data representation and strict internet safety protocols, actually secure that transaction from start to finish? If you can seamlessly connect those dots, you are 100% ready for this exam. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Want to know the answer to that question? Just click the next explainer right on your screen to find out. Catch you there.